Okay, I have this problem. I had a question, a student had a question on this problem in my production and operations class. And I took this problem from Operations and Supply Chain Management by Stevenson, 2024 release. A very good book. If you need a good reference book, it's full of a lot of really good stuff. So anyway, this is where I took this problem from. And and what we have here, let's just read the problem. Manager wants to assign tasks to workstations as efficiently as possible to achieve an hourly output of 31 units. So I put that here under my given area. So that normally, when they're talking about units per hour or something, a lot of times there's a German term called Takt time, and that's what they want, you know, to produce 31 units an hour in order to meet their demand, probably. Uh, that might be one reason, but anyway, they call that Takt time in Germany. The amount of the pulse that you want the production to work at. Okay, so you want it to produce 31 units an hour. The shop works a 60-minute hour, so we're 60 operating time is 60 minutes per hour. We want to assign the tasks in the accompanying precedence diagram, and the times are in minutes, to workstation using the following rules. So, in other words, these are operations that have to be done in order to complete this product, and it takes 1.8 minutes to do task A, zero point 0.8 minutes to do task B, and you can't do task B before A, so that flows this way. So you can't do task H before you do task G. So the products have to be done in that order of this diagram here. Okay. Um, so the questions are, first they want to find the cycle time, and then we want to order the tasks. And it already has the tasks. If you see here in the answer selection, the answers are already here, but if you're doing this problem, you'd have to put these answers in. So they already have it. The first task is one workstation by itself. The second task is two workstations, or two of these, two of these operations. So two operations are in the second workstation. The third operation has three workstations, or three operations, and the fourth workstation has two operations. We want to know what tasks go in there and what time remaining. So let's say this. So let's just kind of work this out. Um, I think it'll make more sense if we just get right into the problem and start solving it. And so basically, this is like a little bit. You might call this like a line balancing problem. So who's going to do what in order to achieve this 31 units an hour? So if you go down, so what I did is this right here is just what we want to find, and that just states restated these numbers here. Um, so let's just get into the solution part of it. So the first thing we're gonna do, I'm gonna go over here to the right, and we have to kind of take this. I'm gonna drag this diagram down so we can see it. So we want to say what task we have. Let me move this down just one. So we have task A, and we want to know the following tasks for A. Well, all these tasks follow A, so we can go. So I'm just gonna say A, and we can say here following tasks. This will make sense in a second why I'm doing this. And we can just say is, uh, well, B, C, D, E, F, and G follow. So I'm just going to go ahead and copy that. They all follow A. Okay. And then we can go with task B. Well, B is just all these over here follow everything to the right of B. So I can go, these all follow B. So I'll copy that and I'll put it here. So I'm just diagramming out all the different following tasks. And then C, we'll just do it in letter order. Well, C, there's only two tasks to follow, F and H. Right, so I'll just go ahead and copy F and H. Well, I can just type FH. Okay. And then task D, what follows D? Well, it's going to be G and H. Let's type it, as quicker. And then task E, what follows task E is G and H. And F, we just have H following F. And G, we have H following G. And H, we don't have anything following it, right? And then the last thing we want to do is we're going to do something called the following task time. And what we could do, we could actually just get those information here using something called X lookup. So I'll go equals X lookup. And I want to look up this value. And where do I want to look it up? I want to look it up over here in my given area. I'm going to hit F4 because I want to copy that down. So I'm going to make that an absolute reference. So when I copy this formula down, it doesn't move from there. And what do I want to return? I want to return these. Also, I'm going to hit F4. And that probably should be good enough. Then we can say that B returns 0.8. So we can just double click this to send it down. And you can see that each one of these, so it does automatically just looked all these up for us, right? Let me put the formula in here. Okay, so now we've got our, so now we can use this now to proceed. So let's just keep going. We could calculate the cycle time, by the way. Let's just go ahead and copy this. And the cycle time, this is the formula for the cycle time. Oh, just paste it in here. Oh, Control Z. Control Z is your friend. Copy. I have it over here to the left or to the right. So this is the formula for the cycle time. So it's the operating time per day divided by the desired output rate. Well, this is operating time per hour, right? Divided by the output rate we want, desired output rate per hour. This actually is equal to this divided by this, right? And we get something, we get kind of a really long, not an exact answer, but I know in order to get the answers the book has over here, we have to round this. So I'm just going to go ahead and go equals round. And we'll round this to 1 decimal place. So it actually, we'll just call it 1.9 minutes. Let me put the formula here. Okay. So that's the cycle time. So we already answered one of our questions. All right, that was one of the questions. We want to find the cycle time in minutes. Okay. And so now what we're going to do, now we have to start filling in this chart here. But before we start filling in this chart, we have to calculate something. Well, I'll just show you. We want to calculate we want to take these tasks, and what we want to calculate are the following tasks. How many tasks are following? Okay. So how many tasks are following A? Well, we have it over here, right? So I can go equals count if these, okay, count if these are equal to, well, I want to F4 this, right? Actually, H doesn't have a following task. Let me do it again. Equals count if, equals count if these, H doesn't have a following task. So we want to count how many following tasks are oh, this makes sense in a second. I'm going to F4 that because I don't want it to move when I copy it down. And we want to count how many A's are there, right? And there's 7. You can count this, there's 7 A's. And then I can scroll this down. And so that's all our following tasks. Okay. All right, so now next thing we want to calculate is something called the positional weight. And the positional weight, I spelled positional wrong, sorry. The positional weight is equal to the weight of this action, this itself, plus the weight of all the following tasks. So I say equals X lookup. We want to look up this. And where do we want to look at? We want to look it up right here. Oop. I'm going to F4 that, right? Because I'm going to copy it down. And then we want to return its weight. So I'm going to F4 that again. All right. So we're going to stop right there and look what we have. So we know that task A is 1.8, right? And then we have to get all the following tasks, right? So we're going to say plus sum if I don't need the X in there. Sum if, well, we want to sum these. We want to sum these. And I'm going to F4 that. When I copy down, I want to move. And the criteria is if it's equal to A. And what do we want to sum? We want to sum these numbers, right? Again, we're going to F4 that. Hopefully that makes sense. So I want it to go here. I want to look up A and get its own weight. And plus I want all the A's here, I want to sum all the following tasks. So anything that has A, I want to add up all the ones over here. That's basically what I'm doing. So it's 6.5. So I just copy that down and we can sum all the other ones. Okay. So, um, these are all the positional weights and these are the following. So that's just how you calculate that. Let me put the formula here. Well, this should actually be, we'll put it on that. Okay. So we had to do that before we start doing the table. So now let's go ahead and do the table. Let's just copy this. Paste it down here so we can start filling this out. So what we want to do, we want to put so it says here in the order, we want to order the following tasks. We want to order this in the most following tasks. So the way, and then if there's a tie, we want to use the one with the greatest positional weight. So I can go equals sort by, and I want to sort this array. I'm sorry, I want to sort this array, and I want to sort it by the following tasks, and I want to do it descending. So I'm going to go -1, and then finally, if there's a tie, then we want to sort it by this. And also we want that to be descending, so we'll go on -1. And then if I hit enter, it'll do something called a spilled array. Now the reason this gives me an error because I have stuff in here. So I'm going to highlight this. I'm going to go clear. It's trying to spill in here. So it did A, B, E. Is A, B, and then E. Yeah, there's a tie here. So it took E first because it has a higher positional weight, right? And then D is next. And then C is next because it's going by the highest positional weight second because this is a tie. So that A and B, that makes sense? So it's sorting it by this, descending, and then if there's a tie, then it's going to sort these three descending. So it should go E, D, C, which it is E, D, C. Okay? So then we can put the task time in here again. So I'm going to go equals X lookup. And we want to look up this value, comma. And where do we want to look it up? We want to look at here, and we're going to F4 because I don't want it to move when I copy it. And again, we want to return these times, F4. So those numbers go in there like that. We can copy that down. Okay, so let's just copy this. Well, we got lines in here that we don't want. So let me just we'll go here to we'll go no border. Okay, we'll put the lines in later. So the time now we got to do the time remaining, right? So the time remaining, well, the time remaining on this one is equal to my takt time or my cycle time minus how much this took. So we have 0 0.1 remaining. So we only have 0.1 minutes remaining after he does this. So that's why this workstation has to be by itself because there's no other task following that. There's no other task following that take only 0.1 seconds, right? These all take a lot more time, right? So that's going to be basically like idle time. We could call that idle time. Okay, this has got idle time. So that worker, when he's done, he has 0.1 minutes left. So I'll just put a 1 here to say that's the idle time, right? You know what? I'm gonna get rid of these. I'm making room for these formulas, and it's making it kind of you can click on that formula and see it. You can click on that and see it. So, you can pause the video and look at it. I showed it a second ago, right? We're taking up too much space of that. So the idle time is, we're going to put a 1 there because it has idle time of 0.1 on that workstation. So the next one is 0.8. So the time remaining is going to be equal to 2 or 1.9 minus 0.8, right? The time remaining is 1.1. And then, so we could do this. We could say if, well, let me just leave that. So there's no idle time here, right? Because we're going to do another thing. Let me center these. It's easy to see. So so we have 1.1 times, so we can do this next one, can't we? So, but how do we reason this out? So we could say equals if this is less than this. Well, if that's less than that, then the time remaining is going to be equal to this minus this. Okay? If it's not, then the time remaining has to be equal to that minus that. Okay? This makes sense though after we do it. So now we have 0.2 left. So if I copy this down, oh, you know what I forgot to do? I forgot to F4 this right here. Because you don't want that to move, do we? Oh, cancel. I'll F4 this. Let's try it again. So we know this is a new workstation, right? So let's underline that. And we know this has an idle time too of 0.2. There's 0.2 remaining. And we know we only have 2.2 minutes left. So now we got to jump into the next workstation. And that's 0.8. Well, 0.8, there's going to be 1.1 remaining, right? And then there's 0.5 left. And after you use the 0.5, there's 0.6 remaining. And then, okay, so this should be 0. So what did I do wrong here? We go less than or equal to. Try it that way. Okay, so this is just, that's like 0, right? It's very small. So, I don't know why we have that shouldn't be like off by that much. Well, this is 0. And then we have 1.4. So we know we have another one. Well, let me get rid of those borders again. No border. So this we have another workstation change. And this we have a workstation change. So the idle time here is 0. And then finally we have an idle time of 0.8, right? So the other ones we don't have idle time because we're continuing on to the next operation. Okay? So let me just do this. Let me do this way. Equals, let's round it. So we don't have that weird, round it to 1 decimal place. Copy that down again. And then, again, we're going to get rid of these underlines. Sorry about all the housekeeping here. Okay, so now the efficiency, how do we calculate the efficiency? Well, this is how you calculate the efficiency. Let me put it over here to the right. The efficiency is the number of stations times the cycle time minus the idle time. So it's going to be equal to parentheses, the number of stations. Well, we probably should put the number of stations here, right? So let me just move this down. Number of workstations is 4, right? We have 4 different workstations. So that's what this n actual. So now I can go equals parentheses 4 times the cycle times, and then minus the idle time. Well, the idle time is going to be equal to the sum product. Let me do the idle time under here. That way we have it. Idle time. That way you understand how we get idle time. So I'm going to do, if there's a 1 here, I'm going to multiply it times this. The 0, that's not going to be anything because 0 times that. So I can go equals the sum product of these, comma these. So idle time is 1.1. So basically it's adding wherever there's a 1, it's adding it. All right. So now let's go ahead and do this again. So equals parentheses, the actual number of workstations times the cycle time minus the idle time, and then close the parentheses. In the denominator, it's the number of workstations times the cycle time. And we hit enter. You get 85. And let's just make that percent. Take it out a couple places. So that's the answer. So that's the answer to that. And these are the numbers you had to fill in. Well, it actually wants, let me go Control Z. It doesn't want that. It wants these numbers. These are the numbers you have to fill in on the question, right? You can see we got all those correct. Okay. So now we're going to have to do the next one. So let me just copy this. And we'll paste it here. And this one is the second one. They want to know. So now we're going to do the greatest positional weight. I did this one. I probably did this wrong. Oh, the following. Okay, and we did following tasks and positional weight. This we want to do positional weight first, and then following tasks, right? So I'm going to go. So let me just go ahead and do this again. I'm going to go equal sort by. You want to sort this array, and it says to do it by positional weight first. So we want to sort it by this, and we're going to do it descending, And then we want to sort it by this. And then -1 for descending. Okay, we get A, B, E. It's going to be the same order basically. And then let's just go ahead and copy these. What do we do here? What do we do wrong here? Okay, this has to be that, right? And this has to be pointing to that. Okay. And you can see we got the same answers here. 0.8, 1.0, these all look the same. So we got it to work out. So basically, since we did the formulas, we're able to, and then also we have to make sure this has to point again to the cycle time. And we get the same answer, 85.5. So hopefully that makes sense. We just answered them. We answered all the questions. Kind of a complicated problem, but once you set it up with Excel, it kind of calculates things automatically for you. Hopefully that was interesting and useful to you. So basically, it's like we're trying to balance this assembly line in the most efficient way possible. And I don't know what else I can say about this. I know it's kind of complicated, but hopefully that was interesting. If you like my video and you haven't subscribed, my picture will come up. You can just click on my picture to subscribe. Ask any questions. And that's it for tonight. Thank you. Bye.